Hello and welcome to your K-nearest neighbors in Python lecture. Hopefully this will be a little bit quicker because I know you're doing both the theory and the code in the same go. But let's do a K-nearest neighbors algorithm using sklearn. So the data set that we're going to look at is the diabetes data set, which we have looked at before, so I'm going to go ahead and not explore it right now, but I will re-show you a little bit about what that data looks like. So the thing that we're interested in predicting is this outcome variable, which is whether or not this observation or person was diabetic. So to build a K-nearest neighbors model, like with every single other model that we've done, the first thing we want to do is make a list of our predictors. So in this case, I'm just going to use 2, and you can use more than 2 features or variables in your K-nearest neighbors algorithm. The reason why I'm using 2 is because I want to show you some visualizations, and as we talked about in the lecture, it's really hard to visualize more than 2 dimensions. I mean, 3 is like already pushing it, and 4 is for sure not going to happen. So just so you know, when you're building these, you can use more than 2 features. The reason why I'm sticking to 2 is just because I want to visualize it so you guys get a little bit of a sense of what's going on. But for this one, I'm going to use BMI and I'm going to use blood pressure. So let's grab our X variables, and that's going to be data, bracket, predictors, and then our Y, which again I said is outcome, so it's going to be data, outcome. Cool. Okay, so now I'm going to put this in a variable just so we can change it pretty easily. I'm going to call that n neighbors, because remember in K-nearest neighbors, one of the things we have to decide on is K. And so in this case, I'm just going to say 5. Why not? We'll try some other ones later. So now I need to create my K-nearest neighbors model, and I'm going to use that, do that in sklearn by using K-neighbors, N-E-I-G-H-B-O-R-S, there we go, classifier. And the K-nearest neighbors classifier is going to take an argument for how many neighbors that we want to have. And I'm going to set that equal, it's actually called n neighbors, equals n neighbors. So this is telling it that we want to use 5 nearest neighbors. Okay. So now that we have our model, we can standardize our variables. And remember, we talked a little bit about why we want to standardize our variables, not just in the general terms of why we standardize them, but specifically in K-nearest neighbors, depending on the distance metric that you're using. If your variables are on really different scales, then the variable that has like a much larger scale can potentially impact that distance metric, like a Euclidean distance metric, more than the variables that are on a smaller scale. So sometimes we just want to standardize our continuous variables so that they're all on the same scale. So I'm going to say z equals standard scalar. And then like we've done before, I'm going to say z.fit. Oh, and you know what I need to do before I standardize anything is I need to split my data into my train and test, because obviously we don't want to leak any of our test set into our model. So I need to go ahead and split that. So I'm going to do that up here. And then I'm going to say z fit x train. And then I'm going to say, let's see. Okay, so I want to do both of these. Okay, so then I'm going to say x z train equals z dot transform x train. And then I'm going to do the same thing for the test data. I'm going to say xz underscore test equals z dot transform x test. Cool. So now all of my variables are z scored. So the last thing that I need to do is actually fit my model. So I'm going to take my model, I'm going to call dot fit on the model, and I'm going to give it x z train y train. And so when we run that, you can see that it's just going to give us, it's going to output a model for us. And we can do things like check the accuracy and stuff like that. But first, what I want to do is, I'm not going to go over all of this code and what it does with you. It's adapted from this website, and I just adapted it for our purposes a little bit. But this is going to produce a plot, and actually I'm going to start running it. It might take a second to load. This is producing a plot from our specific data of what the neighbors and the neighborhoods look like. So we talked about this a little bit in the lecture. This shows you the data points color coded, and then the background shows you if a data point were in this particular place, what would it be classified as? So you can see these interesting patterns. You can see mostly there's blues over here and oranges over here, but you can see that there's interesting little pockets of blue. There's little what would you call it, protrusions of orange over here. But this gives you a little bit of a better idea of what the classification algorithm is doing. And one thing that might be fun is to see when we change K and we create a new model based on, for instance, I just ran it with 25 neighbors instead of 5. We can see how that changes how things are classified. So you can see, for instance, in this case, we have this weird orange protrusion now based on 25 neighbors, but we see an overall pattern that like most things over here are still blue, most things over here are still orange, etc. So we can change that. We can play around with that however we want, and you have the code, so you're welcome to do this as well. Let's see if I change it to 3. What does it look like? Okay, that's interesting. So we see a little bit more blue over here. We see this weird little island of blue here. But this is a good way, if you have 2 dimensions at least, to visualize what the K nearest neighbors algorithm is doing. And hopefully, especially if your K is a little bit low, you can kind of see why that is the case. For instance, you can see like this is an orange point, but it's in the area classified as blue because look, its nearest neighbors are all blue. So hopefully that gives you a little bit better of an idea of what K nearest neighbors is actually doing. When we assess the performance of the model, we do it the same way that we've done before. We can use KNN.score, which is going to give us the accuracy. So we can give it XZ test, Y test, and this will give us our accuracy, which is not great. It's about 65%. It's better than chance maybe, but it's not doing super well. We can also plot the confusion matrix. So plot confusion underscore matrix, and we'll give it the model, and then XZ test, Y test, and we'll run that. So, I mean, this confirms our accuracy. We can see that it's actually making quite a few mistakes. It's predicting a lot of things in the off diagonal, which are incorrect predictions, but overall it's doing okay. All right, so the next thing that I want to talk about is parameter tuning, and we talked about this in the lecture, but now I want to show you how you actually can do this. So looking at the same data that we did before, the simplest way to do hyperparameter tuning is to do a train test split and then split your training test into a training and a validation set so that you are able to test out your different values of K. So I'm going to show you how to do this by hand here, and then I'm going to show you 2 other options. But first, just so you kind of understand what's going on, I'm going to do it by hand. So the first thing that we want to do should actually be really familiar to you because this is what we do all the time, which is to split our data into a training test, a training set, and a test set. And so that's the same thing. The thing that we're going to do next is what's different. So I'm going to use the train test split algorithm again, but you can see that what I'm splitting is X train. So remember we talked about when we are doing this train validation test set, we take our data, we split it into a training and a test, and then we put our test set away and we do not touch it until we have our final model. What we're doing in this second line right here is taking our training data and splitting it into a training set and a validation set. And that validation set is going to allow us to assess how well different values of K do on our data set, and then choose that whichever one does best, and then build a model based on that, and then go back and test it on our test set, which again, we haven't touched until we've figured out our entire model. Okay, so now that we have that, this code actually should look pretty familiar. So what I'm going to do is I'm going to make a list, and I'm going to call it pos k, and actually I'll say pos underscore k, and I'm going to give it a list of possible values for k. Because we're crunched for time, I think I will just do 8, 9, and 10. So this is basically saying I want to test my k nearest neighbors algorithm with values for 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You can obviously test more normally. I just don't want to run that many models right now. And then I'm going to have accuracy, but instead of a list, I'm actually going to store it in a dictionary, and you'll see why in a second. So this part should look actually sort of familiar, because this is similar to what we do when we're looping through k-folds. So we're going to say for k in possible k, or in pos k, we're going to build a model, and I'll call it this, equals k neighbors classifier. There we go. And I'm going to say n neighbors equals k. So this is basically going to loop through, and for each of these values, it's going to use that as the number of neighbors that we want to look at. So then I'm going to fit my model, and I'm going to give it x underscore train 2, y train 2, and you can see from these splits here that what I'm giving it is the actual trained set. I'm not, you can see, touching the validation set yet, and I'm not touching the test set yet. So I'm going to fit that, and then what I'm going to do is I'm going to store the accuracy of this model in the dictionary. The key is going to be the k, and the value is going to be the accuracy for the model fit with k nearest neighbors. So I'm going to say acc bracket k, there we go, equals KNN3 dot score x val I val. So remember, we're using our validation set as a way to estimate the accuracy from our different values of k, but we haven't touched our test set yet, and we actually won't until the very end. Okay, so similar to when we do k-fold cross-validation, I'm going to go ahead and print out, once that loop is done running, I'm going to go ahead and print out the accuracies. So I'm going to run this, and you can see all the accuracies printed out here. So our job is to see which of these is the highest. So what I'm going to do is, you can go through and look. So it's probably, let's see, is there anyone higher than that? Yeah, okay, so 626016. Ooh, we might have a tie. Okay, so I'm just gonna have the computer figure it out for me. So I'm gonna say chosen k equals max, and then I'm gonna say accuracy, which is our dictionary of all the accuracies, and key equals acc dot get. So this is gonna tell me what is the value, or excuse me, what is the key that has the highest accuracy. So let's actually print it out so that we're not just running this for nothing. And we'll run. Okay, so in this case, the highest accuracy was when k equaled 2. So we're going to go ahead and use that. And I'm going to just print chosen k because I want to keep that printing. But I'm now going to build a final model. So what we're going to do is we're going to take our training set and our validation set together and use that to build our final model that is going to be evaluated by the test set. So now that we've made all of our decisions, which in this case was just what is the value of k that we want to use, now that we've done that, we can incorporate all that data, use it to build our new model, and then go test it on the test set. The only thing that we don't want to do is have our test set in any way leak into that model decision making. So as long as we're leaving that separate, we should be good on that front. So I'm going to call this KNN final, and I'm going to say k neighbors class classifier, gosh, this one's very long. And I'm going to say n neighbors equals chosen k. And then I'm going to fit it. And remember how I mentioned that we can use all of our data, like not our test set, but we can use our training and our validation set. So all of that together is in X train. So I'm going to use that. So I'm going to say X underscore train, Y train. And now that I have my final model, let's see how it does. So I can say KNN underscore final dot score X test, Y test. And now before I run this, I just want to point out, notice that I have not, until this very final line, I have not touched my test set. That's the important part here, is we're using our validation set to choose a value of k, but we still need to keep our test set separate until we're ready to evaluate our model. Excuse me. Cool. So our model in the end didn't do so well. It did 56.5% accuracy. Not my favorite, but you know what? That's how things go sometimes. So you can see why it might be a little bit important to make sure that we evaluate our data on evaluate our model on unseen data, because obviously all of the accuracy values that we got up here were different than the ones we got here. They're a lot higher. So that indicates that maybe our model is a little bit overfit and that it's not going to perform as well on out of sample data. Okay, so let's do that entire thing again, but let's do this by hand, but using k-fold instead of just using train test split. So the first part is going to be exactly the same. We're going to split our data set, our whole data set, into a training set and a training set and a test set. But instead of just splitting it again and creating a validation set, we're going to use k-fold cross-validation on our training set to fit and test out the different values of k. So again, I'm going to say for k in pos k, I'm going to create a k-fold object, k-fold, and I'm going to use n splits equals 5 just because we don't have a ton of data. And then I'm going to say KNN for equals k neighbors classifier. And then I'm going to say n neighbors equals k. And then ac k, there we go, equals np dot mean cross, not capital, cross val score, give it the model, give it my training data, give it the test data. Oops, that would be y train. Sorry, there we go. So if you remember back from class, when we use cross-val score, and I need to give it the cross-validation method, this is going to give us a list of all the accuracies that we get when we do 5-fold cross-validation. And this NP mean function is going to take the mean of those accuracies. If you wanted, you could also see which one has the highest accuracy, but for this purpose, I want to see which of our Ks has the highest mean accuracy. Okay, so just like before, when we're out of our for loop, we want to print the accuracy so that we can see them. But actually in the same way that we did before, and let me copy and paste it because we don't want to reinvent the wheel here, I'm going to see which of our Ks has the highest mean accuracy, and I'm going to choose that one. I'm going to fit our model with all of the training data, and then I'm going to evaluate it on the test data. So let's go ahead and run this. Might take a second. There we go. Cool. Okay, so we can see all of the different accuracies that we have, and we can see that when we chose our best K, it was 8. And when we used that parameter to fit our K nearest neighbors model with our entire training set, we got a a test accuracy of about 62.3%. So a little bit better than what we did before, but still not the best. Okay, So the last option for doing this hyperparameter tuning is actually to let Python do all of it for you. It's actually a little bit easier code-wise. So what we can do here is first, well, do the same thing that we've been doing this entire time, which is to split our data into a train and a test. But then what we can do is we're going to build our k-nearest neighbors model. We are, in the same way that we did before, going to make a list of our potential values of k, but this time, just because of the way that the function that we're going to use works, we're going to put it in a dictionary. So I'm going to put ks equals, and what you're going to do is you're going to put the name of the parameter that you're tuning. So in this case, in the k-nearest neighbors, it's called n_neighbors, as we've seen before. So I'm going to say neighbors. And I'm going to tell it to give me, or excuse me, I'm going to tell it what values I want to test. So since this is doing all the work for us, let's do range 1 to 30. That sounds good. So this is going to test all of the Ks that we just listed, and I've listed a lot more than before. So now that we have this dictionary, we're going to use something called grid search. And grid search is actually a little more useful when you have more than one parameter that you're tuning, but it still works here. What it's going to do is it's going to test every single possible parameter value and then spit out a model that was trained using the best parameter values that it could find. So we're going to create an object called grid, and we're going to set it equal to grid search CV. Oops, there we go. And we're going to give it our model. We're going to give it the parameters that it's tuning. We're going to give it this, oops, spelled that wrong, scoring. And by default, this is accuracy, but I just want to show you if for some reason you ever want to use something that is not accuracy as the metric for how well your model did, you're more than welcome to do that. This one just happens to have accuracy as the measure because in this case, that's the thing that we care about the most. And then for CV, you're going to say how many folds that you want. So I'm going to say 5 because I just want to do a simple 5-fold cross-validation. So when we run this, this is going to do all of this stuff for us. It's going to find our best hyperparameter, and it's going to find the model that is the best using those hyperparameters, or in this case, this one hyperparameter. So what we can do is we can actually say grid.fit X train, Y train, there we go. And what this is going to do is this is going to run all the model validation for us, find the best hyperparameter, and when we spit out this, which I'm going to store in the variable KNN mod, it's actually just going to be the best fit model already. So you can see this is a lot less code than the other ones that we've been doing, just because the grid search CV function does a lot of this for us. So I'm going to run this, and it might take a second to run because we are asking it to run a lot of models. Okay, and it's already done. Beautiful. So if we want to know what the values of our parameters are, we're going to have to look at the model and then ask for the best underscore estimator underscore dot get params, and then bracket n neighbors. Okay, that was a lot of stuff, but this is basically saying from your best model, get all of the parameters, including our hyperparameter, and just this is telling it only show me n neighbors because that's the only hyperparameter that we tuned. So when I run this, you can see that the K that it chose was 28, and that's what it deemed was the best model. There you go. And we can also use this the same way that we have before to get scores and stuff like that. So we can say KNN mod.best score. And you can see that you can get the highest accuracy that it got and etc. So there's more attributes that you can pull from your model when you use grid search. If you're interested in seeing what those are, you can go to this website and you can see all the different things that you can pull from this model. But like our other models, we can also use this to score and predict. So I can say KNN mod.score and give it, let's see, X test Y test. And when I run this, this is essentially our like out of sample prediction. So how well does it do on unseen data? And this is actually pretty good. It's definitely a little bit better than the other models we've seen. It's getting about 66% accuracy. So obviously it's doing something right. Okay, so that is all that I have for you for k-nearest neighbors and then for very basic hyperparameter tuning. Now I want to make this clear because I know when we first started doing cross-validation, people were a little bit confused. You only have to do one of these three options and you can choose which one you want to do based on the circumstances. I would recommend option 3 just because Python was nice enough to give you a simple function that does a lot of this for you. But I did want to show you these 2 ways to do it in case you need to do it that way, and just so that it helps you know kind of what's going on under the hood when we're doing this train validation test set split. Okay, hopefully that made sense, and I will see you next time.